Hello and welcome to Java Collections. My name is Praveen, and in this video now we'll talk about linked list. Starting with linked list, it's a linked implementation of a list interface. So when we talk about linked, that means my first, next, and the element which is coming after next are linked. It's like we have first node, second node, and third node. They are linked together through a connections. So that's what make this linking implementations, where the next elements are not contiguous elements, not one after the other elements, but they are linked on the memory areas. We'll come to detail about the linked implementations. First we take it's a collection. It has every element, every operation, what we can do with other collections. It implements all list operations, and it permits all the elements, including null. In addition to implementing the list interface, this linked list provides some uniformly named methods so that we can get, remove, and we can insert an elements at the beginning of the list, at the ending of the list. So that's the advantage we have. So linked list, apart from ArrayList, it will give me some extra methods that I can directly reach out to the first element or to the last element. I need not to specify the index of it. Since these elements are linked together, they know what the next position that we have. So these operations, these specific operations where I can reach out to the first, middle, or the last elements, these operations allow linked list to be best suited to be implemented as a stack, as a queue, as a double-ended queue. Like these are some of my data structures which can be implemented using a linked list. Okay, moving forward, linked list is a doubly linked list implementation of the list and DQ interface. This will allow see, the point with an array or with an array list is when we insert an element, the entire list has to restructure. Let's say we have an array list of 10 elements. The moment I'm trying and adding the 11th element, it will itself create another bigger list of say 20 size, and then it has to move all the 10 elements from the smaller array list to a bigger array list. So this movement, this restructuring will happen with a normal array list, because we have contiguous memory location, or we have called this as a fixed memory location. In linked list we have got dynamic memory allocations, so it will give me in constant time. If I have to insert, I have to insert only one element. If I have to remove, I'm removing only one element. I'm not changing the structure of my parent list implementations. So that's the best advantage we have. We will get the best performance with it, as it is constant time. Constant time is nothing but big O of 1, so it will take the fastest route for it. In other words, linked list can be searched forward, backward, but the time it takes to traverse the list is directly proportional to the size of the list. We can traverse it since we have got the head of the list. We can traverse from it, but the insertion and removal part is very fast because that restructuring thing is not happening here. Okay, moving forward, some of the common method of a linked list here. It's simple. We can add an element, add an element at a particular index. We can add the new collections here. Now these are some of the important methods that we have: add first, add last. So this is something which is not coming with the normal array list implementations. So we'll start with some basic operations. Moving from presentation, we'll start with the code. You can start with any ID of your choice. I prefer IntelliJ. We'll start writing some code here. We'll write a my linked list demo. I'll just remove all other ones, and here I quickly write a main method here. We will quickly write a main method here, and we'll start with the basic code. So here we have got linked list. Keep it of string type. We'll say my linked list. We can keep the parent as list also. It does not make any difference. Oh god. So what I need to do here is I can add some element here. Okay, so these are some of the elements I have in my linked list implementations. So first, starting with linked list, what we can do is we can take it as just like an array list. It has all the operations that we have seen in the previous version of an array list class. So what we can do here is we can check the size of an element, like how much element do we have in this list. I can see I'm not doing the complete detailed one. I can just go in quickly. I'm doing this. What all methods do we have? Need not to test it. You can test it. We have already tested it a couple of times. We can start with my linked list dot iterator here. See, this gives me a list iterator also, since this is a specific version of list which can iterate forward and backward both. So I can take an iterator here and a list iterator also. After this, going forward, we can use a clone method here, which is, I think, no more supported nowadays. Okay, so next is what we can do is we can add all here. We can add a new collection over here. It's kind of a, say we have a new linked list here. We keep it specific to string. Okay, leave it. We can add our, we can say we can add a new collection here. Okay, so moving forward, what we can do here is, let's say for some time we can just comment it. What we can do next is we can clear out the collections. It will make my collection blank. Next is I have my linked list and I have a 2 array over here. I can take a specific array and I can convert my list. I can pass on that list element to an array element over here. Next, what I can do is I can keep a sublist of it. I can give it the starting index or the ending index, and it will give a smaller version of a collections. Last we can do is we can have a shuffle here. Okay, shuffle is also no more supported nowadays. So these are some of the common methods that we have seen couple of times. You can right click and we can test all the elements. So I'm not going forward with this. What we can do is we can come forward, like these are some of the methods which is specific. These are the methods which is generic to all the available collections. The same goes for my linked list also. What I'm more interested in here is we should take some methods which are more specific to linked list also. Like, say here I'll start writing as we have to add the element to the first of my linked list. How I can do this is, we have got a list and we have an, see, the add first elements. So it will take the first element and we'll say it's a new first element. My first element will return me void, so this cannot be clubbed with a string over here. I just need to take it out. And I have to just put it over here. We have added element to the first, and after this we'll just print the added element over here directly. I think this is the way we can do it, and we just right click this and we will right click and see what is the output here. So we add the element to the first of my linked list. Here I have got a new first element here. See, I have not specified any index. The same can be achieved with my linked list. I want to add an element and provide an index. My index is like 0th index and my first element. It should work the same way. We'll right click and check it. See, my 0th is the first index. Since my array is a 0 base, so we'll start with the 0th index. So that is my first element. But instead of specifying the index explicitly to 0, I make it as add first. So these are the methods which is not supported in other ArrayList or other linked list implementations. Okay, moving forward, next what we can do is we have, similar to add first, we have an offer first method also. It will offer whether we have this element has been added or not. So has added or not. This is a boolean one, so it will return me. So we can just club it out and it should work. Sorry, we'll just right click and just test this. It should return true in that case. That okay, yeah. So it has added the element. So it will give me an option. Add first will directly go ahead and just add the element. If it is not available or not possible, it will throw an exceptions. Offer first, on the other hand, will just try and offer. If it is there, it will add it, otherwise it will just return false. It will not blow up. Okay, so moving forward, similarly we have got for this elements we have got linked list, we have got an add last also. So we have added a last element here. Similarly we have linked list and we have to offer the last element offered. So these are something like we are playing with the data structures. Like we are writing some code which can give me, I can add an element by when I specify the locations, the starting of the element or the ending of the element. Similarly, like once we have added all these elements, I will just try and print this. Say my updated linked list. We'll right click and run this and see what all elements so far we have added to the first or the last of it. See, has added or not is the first elements, then we have got last element offered. See, we have played around with couple of elements by starting it on the first element and on the last element. Moving forward, similarly what we can do here is, we can retrieve out the elements. So we can say element as at index 1 is, we have my linked list and I'll just pass the index 1 here. We'll right click and check it. So element at index is my first element, which is nothing but this element. So similarly we can go out with, say element at my first is, instead of writing 1, I will just write get first. In get first I need not to specify the index locations. Similarly we have to take it element at my last is, I have to get the last element here. Again I need not to specify the index of this element. See, so my element at first is, has this element added or not? This is my linked list and this is the last element which was offered. So this is the last element. So by using the specific methods we can access to the first element or the last element of my linked list. Moving forward, this is something similar to when we just see, either we can add an element or we can offer an element. What happens is we can pick out the information also. We are picking the first element. So just to peek is just to see. If you just go and check what element you have, so here you can peek it. Similarly we can make it as peek as the first element over here, and when we do this we just change this to last here. So we are picking the element simply here. We are picking the first element and we are picking the last element. We can right click and check. See, the first element is similar to my first element. Picking the last element is just the last element. Or see, peek comes with when we talk about the stack data structures. Stack gives me a feature to push an element. Like when an element is inserted, we pop out an element when the element is retrieved and removed from the top. The next is the peep element, where we just retrieve the elements. We need not to delete that element. So that is my peeking first and peeking last elements. So these are some of the methods that is very specific to linked list implementations, where we can play around with the first last elements, how we can retrieve those elements. Okay, so next is we have linked list and we have a specific version of an iterator which is called descending iterators. We need to move forward, we can move backward also. It is like we are starting from the last element and going back to the first element. We can just take a quick look here. It's a descending iterator. Just quickly see what this is gonna return me. This is gonna be a return of an iterator only. For this I need a placeholder here, iterator of my string. Say my descending iterator. So with this descending iterator, what I can do here is I can check, does it has the next elements even though moving backwards. Element descendings are we check the my descending iterator and just take the next element of it. So if we right click and run this, see element we are descending see we are starting with the last element of it, second last, third last, till we go to the first element. So this is another version of descending iterator where we are iterating it backward, not from the starting of the list but from the ending of the list. Now we have some more methods specific to stack implementations. I say we have a my list, linked list, and I can push an element. This is similar to I'm adding a new element, adding, or say we are pushing a new element to the linked list. Okay, after push, similarly what we have next is we can pop out an element. Pop will basically remove the element, whatever element has been added to the last. Whatever element we have on the top will be removed. See, we have just pushed an element, this will be pushed to the top of it, and this is just removed. After this operation, we just see how my linked list looks like. I think before this we should take a look what we have before doing the stack operations and what we have after these stack operations. Okay, so before this is we have added a new element on the first element and last element offered. That means no change has been done. We added this element and we removed that element. Okay, just say this, we move out of here and we do it afterwards, and then we just put it over here. So what we are doing is we are adding an element and printing it, then removing an element and then again printing it. Okay, so what we have done is we had an element, see, has added or not is my first element. After this we have pushing a new element to the linked list. So this became my first element, which is pushed at the first of it. So when I push that element, similarly when I have to remove it, this was the first element which got removed, which got popped off. After popping off, similarly what we can do is, now this will make more sense, picking my top element. So here my linked list will give me an offer that I can, my linked list, and I can peek an operations. I can peek what is coming on the top. We'll just right click and run this. Okay, so after removing this element has been removed. This is what we have got left off, and this is the first element we are picking off. So this is something specific to, these are some methods which make it best suitable to be used as a data structure for stack, queue, linked list. Okay, next after this is just how we have added an element. We take a linked list and we can remove an element. We can remove a particular, we just remove it. We can remove the particular element. We can remove by passing an index of the element. Remove by using the index of the elements, and then we can remove the first element over here. So this will remove the first element we have added, and this will remove the last element that we have added. Just like we are adding first element or offering first element, so we are removing first elements. Or just give me some methods like I can remove the first occurrence of something. So we have plenty of methods to play around just to see the which locations first occurrence of my one particular object. So the moment this will occur first will be removed. So we have couple of methods. We have seen some implementations and they will be removed, they will be implemented as we go along. Okay, so coming back to the presentations, we just take a quick look some of the methods. So here that we have discussed at add first, add last, and some of the older methods. Moving forwards, these are some of the basic linked list operation that we have just seen. We can see the size of my linked list, whether it contains an object, whether this is empty or not, how we can iterate through a linked list. This is similar to any other collection that we have. Going forward, we can clone an element and just make a clone copy of it. We can add a new linked list and just add it to it. We are adding a complete new collection to an existing collections. So what we can do is we can contains all, it will check the another list that is already added. Moving forward, we have taken a string array, we have moved all the linked list elements to this array, and then we can iterate through every element of it. We can keep a sublist of my linked list, giving the starting or the last index of it, And then we have got a shuffling, like this is nothing but we just shuffle off the elements of linked list. So as whatever order they have been inserted, that order will be changed, will be shuffled back. So we can collections.swap, we can swap that linked list, though we have not discussed it, but this is some of the common methods. Okay, after